This is not for me, this is for you. And Skylar in particular, because he needs it.
A lot.
A lot, okay. Cool, a lot. So, how do we determine, so in order to name these things, we need to first determine what kind of ionic compound we are naming. All right? Or it might not, sorry, not ionic, inorganic compound. So these are all inorganic compounds, the compounds that I've written. What are our options? We have, let's see, we have molecular compounds, we have ionic compounds, and we have acids. Okay? So the first thing for you to do when you approach a compound, what's up, Jason? Why are you doing that with your face and your hands? Okay, cool. All right. So how do you determine if something is ionic? We're looking at, I'm going to say, we're going to look at a metal and a nonmetal. Okay? That is our first thing that we look at. Okay? Especially for formulas here. So this middle one, we have potassium, which is a metal, and chlorine, which is a nonmetal. This is our only one that is an ionic compound, okay? So I'm going to go ahead and just label this ionic. Okay, so now we have two other kinds of compounds. What are they? This one is an acid, right? And what's the one on the right? Molecular. Okay, so how do you know that this one is an acid? It has a hydrogen in front. That means it's an acid, okay? This one over here, the molecular compound, has two nonmetals. So that makes it molecular, okay? The ionic has a metal plus a nonmetal. Non-metal. So that makes it ionic, okay? So once you get those guys, you can start naming them, okay? So what do you guys want to do first? Let's just do the acid first. So there's two kinds of acids, right? What are my two kinds? We have binary and we have oxyacids. Okay? So an oxyacid is what it sounds like. It has oxygen in it. Okay? H2SO4, that has oxygen in it. Therefore, we have to go by the oxyacid naming convention. Okay? So oxyacid naming convention has no prefix. No prefix. Binary has hydro prefix. Okay? You guys got that? Give me an example of a binary acid. HBr. Okay, perfect. HBr. Hydrobromic acid. Very good. So our binary acids will always have that hydro in front of it. Can anyone think of a binary acid that has an anion that is not an oxyacid and is not an element by itself? How about HCN? How would I name that one? Hydrocyanic acid. Cute, huh? Yeah. Yes. They have ick, but they also have us. Okay, so let's talk about those. So binaries are pretty simple. Once we get to oxyacids, it starts to get confusing and it's very easy to mix them up with the binaries. So the oxyacids do not have a prefix. When we're looking at the polyatomic anion, polyatomic anion. Okay. If the ending has an 8 at the end, that will have an ic ending in the acid name. Okay? If the ending has an ite at the end, what ending will it have? Us. Okay, so let's look at our example, H2SO4. What's the anion? Sulfate, right? SO4 2 minus. It has an 8 ending. So this turns into what? Sulfuric acid. H2 plus SO4 2 minus. Sulfuric acid. What if I want to write sulfurous acid? What would that look like? H2SO3. This is sulfurous acid. Because SO3 2 minus is sulfite. Okay? Cool. Are there any questions about these, Shannon? Oh, how do you decide? So that is a great question. SO4, let me change colors. Okay, so SO4 2 minus is sulfate. And you just have to remember your polyatomic anions. That's how you decide. SO4 is sulfate, SO3 is sulfite. Okay, and this is why I had you guys do so much work to memorize these. That's how you decide. Any other questions, John? Yes, 8 always has, okay, 8 ending, or 8 compounds always have one more oxygen than the ite compounds. Okay, so if you can just remember one of them, if you remember phosphate, right? If you remember phosphate, then you know what phosphite looks like. The charge stays the same, but the number of oxygens changes by 1. Yes.
So how do you determine if it's an acid from the ionic one is hydrogen fluoride or hydrofluoric acid?
Oh, I see. Okay. Another good question. So, whoops. Go back to a color. All right. So you're asking about HF aqueous and HF gas or liquid. Okay? So this in gas form or liquid form or not acid form basically is hydrogen fluoride. This is hydrofluoric acid. I will tell you to always assume that it's aqueous. Okay? If I want you to name it otherwise, I will indicate otherwise.
Okay.
Always assume the acids on my exams and quizzes are aqueous. And that means you name them like an acid. That's a great question. Thank you for pointing that out, because there is such a thing as hydrogen fluoride, and in the gas phase, acids are not acids. They're molecules. They're just molecules. Hydrogen sulfate? Yes. Yes. So in like the gas phase, it would be hydrogen sulfate. But you guys do not have to worry about that for this exam. Do not name them like molecular or ionic compounds. Do not name them like ionic compounds. Okay? Alright. Ionic compounds. There's... I'll change the color. So there's 2 kinds of ionic compounds. You guys might not realize this, but there's actually 2 ways to name these. The first way is when you have a type 1 metal. The second way is when you have a type 2 metal. The type 1 metal is a metal that only forms one charge, okay? Only forms one charge. Okay, and a type 2 metal forms 2 charges. Okay, and you guys are lucky because I'm giving you a periodic table with all the ions on it today. All right, so what you guys have to do is determine how to name it based on how many charges it forms. Okay, so KCl, which category does this fall under? Daniel? Type 1, why? Potassium doesn't form 2 charges. Potassium is just a single charge alkali metal, right? So we name this by writing the name of the metal, the full name of the metal. We're not calling it potasside or anything ridiculous like that. You just give it the full name of the metal. And then chloride changes from chlorine to chloride, okay? Because that's how you name that anion. Potassium chloride. That "ide" gets added to the stem. Okay? For a type 2 ionic compound, can anyone give me an example of a type 2 ionic compound? Iron something? Give me a compound. Give me a compound. Lead oxide. Thank you. Okay, so which lead oxide do you want me to write? Give me anything. Lead 2 oxide. Thank you. You actually picked an ion that lead forms, so that's great. All right, so lead 2 oxide. This looks like PbO, right? Okay, so why do I need to include that Roman numeral 2? Yeah, lead can also form a +4 charge. Okay, so we need that Roman numeral here to indicate which lead we're talking about. Okay, you don't need a Roman numeral here because when we talk about potassium ion, it's always K+. There's never going to be any confusion there. So that Roman numeral is there to prevent confusion. When I say lead oxide, I need to specify it's lead 2 oxide and not lead 4 oxide because that changes the formula. It changes the entire compound. Does that make sense? So luckily you guys are getting a periodic table which will tell you which ions they form. You guys will not always get this table, just for today, okay? And then you can keep it for your own purposes, okay? Yes? Yes. Okay. Shall I move on? Is that good, Skylar? Cool. All right. So let me move on to molecular compounds. All right. So these are the ones with the Greek prefixes. Greek prefixes. Okay? So I guess I should talk about the prefix mono. Mono only goes in front of the second part. Mono only goes in front of second component. Okay, and mono, that's the only really special case. Okay, so how would I name S2F10? Disulfur and decafluoride. So we have di and deca. Deca means 10. Okay. How about this one? Carbon monoxide. Notice how this monoxide, this mono, only goes after the second guy. It doesn't go after the first one, even though there's only one carbon. Okay? Skylar, you good? Everyone else good? You ready? Okay.